Okay, so remember that whenever you are writing down the answer, you're going from the previous step to the next step and then writing down the reason for that, okay? I'm gonna change the color on this because I feel like that's hard to read. Yes, John. Number 3? Okay, hold on a minute. Questions on 1 or 2? Yes, you can. Yes. Property of equality. And so if you want to write EQ instead, that's okay. Okay, I'm writing subtraction, property of equality. You can write property of equality like that, but you need to have one of those two things, okay? Okay, first of all, number 1, you need me to walk through that one? Max? Okay, so you're going from the first step to the second step. So what did they do from here to here? You write that on this line. Okay, so it looks like we're just putting together the 0.2x and the 2x. So that's adding like terms or simplifying. Tell me why that's not addition, property of equality. Sarah? Good. It is not on both sides. When you do addition, subtraction, multiplication, or division, property of equality, that's something you're doing on both sides of the equation, right? So that one is either combining like terms or simplify, not addition, property of equality. And addition is not a thing, okay? If you're saying addition, that you're referring to addition, property of equality. Wrong. I got it right, but like I don't know why. To clear the decimal is just, yeah, and I mean you wouldn't have to do that if you were dividing it by your calculator by yourself, but yeah, they're just trying to get rid of that decimal. So from here to here, we're doing what on both sides? Subtracting what? 12. Okay, so here we're going subtract 12 on both sides, and it disappears over here and it becomes 27 on the right side. Then again, just because of trying to get rid of that decimal, they moved it over 2 decimal places to the right, which is really the same thing as multiplying by 100. Okay, so that's multiplication, property of equality. From here to here, we multiply by 100. And then from here to here, we're dividing both sides by what? Yeah, 225. Okay, so it's a good idea to kind of go through and sort of solve the equation yourself just to make sure it makes sense what you're doing from step to step. And so you can maybe think about a little more easily what operations you're doing. Max. Uh-huh. If you were distributing 100, the thing in here has to be 2 terms, either addition or subtraction, because distributing means you're multiplying across the parentheses to more than one quantity inside. So it could be that there's 2, I mean, that most typically you've got like 3x plus 5 or something, but there could even be 3 or 4 or 5 or 6 or some kind of numbers, but it can't just be one number. If it's just one quantity or one number, then you're not distributing, you're just multiplying. Well, it could be an equal sign. It could be like 3x plus 5 equals 0.25 or something. And if you decided you wanted to multiply both sides by 100 to get rid of that decimal, you would multiply by 100 in one step, and then your next step would be distributive. So when you do that, it would be 300x plus 500. This is the distributive step, equals 25. Okay, so from here to here would be distributive property, but that's because there's a plus in there. If there's not a plus or a minus, it cannot be distributive. Good questions. Okay, For number 2, on, that says equality there, it's hard to see it, but it says equality. For 2A, where it says combine like terms, what's something else that you think you could put there? So going from here to here, combine like terms or simplify. So it's all right if you want to call that simplify. Okay, so they're just saying you can take that 3x and that 6x and put it together and call it 9x. Okay, put 3 and 5 together and call that 8. You, again, do not want to call that addition property of equality because you didn't do it on both sides. You left the 80 as it was. You didn't do anything to the 80, right? So we didn't do something on both sides. We're just simplifying the left side. Okay, other questions on number 2? All right, so this one is distributive because we're going from the parentheses here to getting rid of the parentheses. So from there to there, that's distributive. Okay, then we're subtracting 6x on both sides, so subtraction property of equality. Why did I write division or multiplication on the last one? What are you dividing or multiplying by? -1. You don't have to say both of those. You can say either division or multiplication. You don't have to have both of those. So some people look at that and think I'm going to get rid of the negative sign, I'm going to multiply both sides by -1, and others think I'm going to divide both sides by -1. So whichever way you think of that, either one of those would be okay as your reason. Again, make sure you're putting property of equality on those. Technically, distributive is not a property of equality, it's just a property. If you write property of equality there, I'm not going to be upset about it, but I am going to be upset if you're not writing property of equality and other things. Because again, remember, sometimes there's property of congruence also. Okay. For number 4, we're subtracting from here to here. We're subtracting 6m on both sides. From here to here, we subtracted 5 on both sides. And then from here to here, we're dividing by 2. Okay, so these are proofs because you're just justifying your actions from one step to the next. Okay, here is this proof. This is subtraction on the first one. I know it's a little bit hard to read that. That is subtraction. Tell me why this is symmetric. Why is that symmetric? What do you mean it's the same thing? Okay. Right. When you switch the sides, that's symmetric. Symmetric is switching the sides. Why is number 7 reflexive? Yeah, same exact thing on both sides. Again, you can kind of think of that like, I don't know if I said this very good, I don't think I did. If you look at yourself in a mirror, you see your reflection. So your reflection sounds kind of like reflexive, and it's like the same thing on both sides. You look at the mirror and you're looking back at yourself. Okay, symmetric is switch sides. Reflexive is same thing on both sides. Okay, now for the ones over here, So again, technically that's not supposed to be an equal sign, but if you put it in, I won't care. Now, why on number 10? Why is number 10 division and not multiplication? Braden? Okay, why can't I say that I'm going to multiply that by 2 and multiply that by 2? Why can't I call it multiplication? Yeah, you got to make sure you go forward, okay? Sometimes that gets people, so watch out for that. You have to go from the if to the then. You always start here and tell me how you're getting to the end part. Okay, so what did you do to the if to get to the then? So that one has to be division. If you called it multiplication, that would be okay if you were thinking multiply by a half, right? If you did multiply by 1/2 right here, instead of dividing by 2, that would be okay. So if you said division and I said, why'd you call it division? And you said, sorry, if you said multiplication, I said, why'd you call it multiplication? And you said I multiplied by a half, then I'd be okay with that. But if you were thinking multiplication because you were trying to go backwards and multiply by 2, that would be a problem. So what happens in a situation, I just mark it wrong and then I ask you, hey, why'd you say this? And then if you tell me the right thing, you get a point back. Braden. If you can avoid me having to ask you about it if you do that. Yeah, that's a good idea. I mean, if you show me like what you're doing, I'm multiplying by a half on both sides here, and then say multiplication, then I would know what you were thinking and be good. Yeah. Okay. So number 8, let's talk about transitive and substitution. So number 8, tell me why that's the pattern for transitive. Why is number 8 the pattern for transitive? Explain what's happening there. Diamond? Okay, so if this is your A and this is your B, what is this? That's C. And then what's that equal to? A. So technically on this one, it would be if thing 1 equals thing 2 and thing 3 equals thing 1, then thing 2 equals thing 3. But yeah, so for transitive, you have to have an entire side of the equation that disappears. Okay, an entire side here has to match an entire side of the other equation. There has to be the same exact thing on a whole side of both of the equations. And that way you can wipe out that. It's kind of like a middleman you're crossing out, and then you can connect the other ones to each other. Can somebody explain why substitution is also the correct answer? Anybody who hasn't talked to me today? Jake, I'm seeing your nose. I don't want to see your nose. Jerron, your nose is poking out now too. Can anybody explain to me why number 8 could be thought of as substitution? Number 8. Diamond already answered something. I want somebody else to talk to me. And actually, Blair already answered the question too. Oh, you did.
See, I would answer, but I don't know. All right.
So what does substitution mean?
Oh, I know.
Jake, try.
Because like, so like, it would be like, so since they're all equal, and you have measurement before, you put measurement before, you say since 3 and 4 are equal, you could like plug in the 3 and then 4 right in the equation.
Okay, so if he's thinking if you started with that equation, you could take out angle 4 and you could put angle 3 in its place, and then you'd have this. That technically it'd be backwards, it'd be flipped around. So I think transitive is a better answer, but substitution would work. Okay, for number 12, why is that substitution but not transitive? So let me get rid of this. For number 12, why is that substitution but not transitive? Max? Okay, that's why it is substitution. So it is substitution because if n is 33, we're basically saying, that's a little bit. We're basically saying, okay, n's 33, so let's go ahead and put that in right there in place of n, and then we'll have 33 plus r equals w. Tell me why it's not transitive. So that's why it is substitution. Tell me why it's not transitive. Simons? Okay, so we need, again, for transitive, we have to have a whole side of the first equation that matches a whole side of the second equation. So let's count here. This is thing one. Is that the same thing as thing one, or is that something different? So is that n plus r, or is that a new thing? That's a new thing. So this is your thing one, that's your thing two. Is this thing one, thing two, or something new? Something new, so that's your thing three. Is this thing one, thing two, thing three, or something else? So that's your fourth thing. If it's transitive, there can only be three parts because you have to be able to repeat one of the sides of the equation in the other equation. So if you are not able to do what I did up here, if you're not able to say this whole side matches this whole side, then it cannot be transitive. Okay, so if I look and say, okay, I have n plus r as a whole side, let me do this. I have n plus r as a whole side. Do I have n plus r here? Nope. Do I have n plus r there? Nope. Okay, what about w? Do I have w here? Nope. Do I have w there? Nope. So therefore, it cannot be transitive. Okay, thing one equals thing two, thing three equals thing four, not going to be transitive. So those are kind of tricky. The transitive substitution ones can be a little bit tricky. If you weren't sure which one to guess, if they're equations, you should guess substitution. Because sometimes, like this one is substitution, but not transitive. The ones that are transitive for equations are also going to be substitution. So whenever it is transitive for an equation, it's also substitution. Those always kind of go together. But if it's substitution, it might only be substitution. So if you're going to guess, you guess what? Substitution, because that covers both of those situations. So if you're really not sure, then you guess substitution. The exception to that being, what is this? If angle 1 is congruent to angle 8, and angle 8 is congruent to angle 3, then, Colleen, what would be the conclusion? To angle 3, good. What is that statement? Transitive property of what? What is that statement? Colleen, you can answer if you know, but this could be anybody. Of congruence, right. That's transitive property of congruence. There is no substitution that works with congruence. Okay, this cannot be substitution because it's congruence. So if you're going to guess and you're not sure is it transitive or substitution, if they're equations, you guess substitution. But if it's congruence, it'll never be substitution. Congruence can be reflexive, symmetric, or transitive. The substitution of congruence doesn't exist. So if it's congruence, it's never substitution.
Wait, so do you know congruency is like an example of the word congruent?
If the statement itself has congruence, then it's something with congruence. So maybe it's like the definition of congruence, or maybe it's like a midpoint or a angle bisector or something where you get congruent things. But if it's a property with congruence, it'll be reflexive, symmetric, or transitive of congruence. Okay, so that is I know that's a little bit tricky. Those are sort of details there that can be a little confusing. Okay, so all of these. Oh, and by the way, on part 5, I think yours had a congruent symbol there on 5. That needs to be an equation. You cannot do subtraction with congruences. So that needs to be an equation there. That was just a typo. So see how this one is transitive, but then it's also substitution. This one is transitive, but it's also substitution. And the last one is transitive, but it's also substitution. If it's transitive with equations, it's also substitution. But sometimes substitution is just substitution. Questions about 1 through 7, Brady? If it's reflexive, you would have to write the same exact thing on both sides. So if it was reflexive, it would say B equals B, or it would say A equals A, or it would say AB equals AB. You will physically write the same thing on both sides. Reflexive will not be an if-then statement, okay? Reflexive, notice if this one was reflexive on number 6, it's just an equation, there's no if-then. Okay, for symmetric, it'll be if-then, because it'll be like if it was symmetric, I would go if B equals A, then A equals B, and I would switch the two sides around. Okay, for this one, the reason that it's transitive is because you're saying B, which is this side of the equation, is equal to A, and B is also equal to 0. You can wipe out a whole side of the equation and make the other things equal to each other. Okay, but if it's reflexive, reflexive should actually be the easiest one to identify because it will say the same thing on both sides of one equation. There's no if then, it's like a very straightforward, if it's equal to itself, then it's reflexive, okay? All right, how about one's down here? Yeah. Why is number 10 what? 50? Yeah, you multiplied by 5 on this side. To cancel it, like you're trying to cancel the denominator to solve the equation. So if you have 2/5 x equals 10 and you multiply by 5 over 1 on both sides, that'll make it 50. That'll cancel. $11, yeah. Cleaning up my answer key here a little bit.
Yeah, I did see.
You did what?
I thought that one better than
Oh, was there some garbage there that I just covered up? Was that on yours too? Okay, that's garbage. Ignore that. Okay, so if JK equals 20 and AB plus JK equals XY, then because JK equals 20, that means that you can replace JK with what it's equal to, which is 20. So we're taking out JK and we're putting 20 in its place. So AB plus 20 equals XY. XY. Okay, could you have called that one transitive? Next question. No. Michael, can you explain why that's not transitive? Okay, it's substitution because you're replacing JK with what it's equal to, right? Again, remember for transitive, it has to go, if thing 1 equals thing 2, then I've got to have a repeat. Either this whole thing has to be thing 1, or it has to be thing 2, or this thing has to be thing 1 or thing 2. I've got to have a whole side of the equation that matches from here over to here, and I don't have any matching sides. So it would be like, this is thing 1, that's thing 2. This is thing 3, that's thing 4. So it can't be transitive. If you're just replacing like part of a side or like one term, that's a substitution. All right, let's kind of talk through these. The first one, angles that are complementary have measures with a sum of 90. Angle A and angle B are complementary. Therefore, angle A and B have measures with a sum of 90. Is that valid?
No.
The first one? Is the first one valid? Yes. Law of what? That is detachment. Okay, this one is detachment, valid detachment. All right. Because this would be if then. If two angles are complementary, then their measures add to 180. I'm sorry, then the measures add to 90. So here are two angles that are complementary. Therefore, that statement applies to those angles. For detachment, remember it should be an if then in the first spot. And then the second spot needs to be an example of the P, an example of the hypothesis. Okay. Complementary angles. Oh, you know what? Okay, here's the problem. This is actually a bad question. Here's the deal. That's a definition of complementary. So the problem is that it actually is true. It is valid because when you switch, I mean, like, if they're complementary, they have to have measures add to 90. So I take that back. It's valid because it's referring to the hypothesis, but even if you switch that around, it would still be valid. Okay, so Diamond, the first thing you look at is, does the second sentence refer to the hypothesis? Yes, it does. Therefore, you're able to apply that statement to the specific example.
So it automatically takes it out of
Yeah, so if you read it in order and that second sentence refers to the beginning of the first sentence, then it should work out to be detachment. Okay, if you switch two and if you switch the second and the third, it would still be true, but that's just because that's the definition. Okay, so that one's valid law of detachment. Why is this one, why do I have an unhappy face there?
Because B is referring to the
Duran.
Because B is referring to the
Okay, so we don't know why Fido's happy, right? It says if a dog eats dog food delights, then the dog is happy. There are other reasons Fido could be happy. What are some other reasons Fido could be happy? Could have gotten fed with food that he likes. Could have gotten water. Maybe Fido got to go on a walk. Maybe Fido got to play with his doggy girlfriend. Okay, there's lots of reasons why Fido might be happy. It's not necessarily because he ate dog food delights. So again, the problem is when you refer in the second sentence, when it's referring to the conclusion of the original sentence, that will be an issue because it's trying to get you to think about the converse of that statement, which does not have to be true. Not every dog who's happy has eaten or will eat or is eating dog food delights. If you switch the second and third on that one, would that take care of the problem? Yes. So if we switched around those two, then it would be valid and it would be detachment. As it is, you always read it in order, and as it is, it's not valid. Okay, if a number is a whole number, then it is an integer. If a number is an integer, then it is a rational number. If a number is a whole number, then it is a rational number. Valid by, that is syllogism. So remember that for syllogism, it goes, the ending of the first one has to match the beginning of the second one, and then you can mush together what's left over. So if a number is a whole number, then it is a rational number, and that's what part C says. Yes. Yeah, syllogism, when we talked about syllogism, I think I might have mentioned that it's kind of like transitive, in terms of the pattern type of idea. You do have to make sure that for syllogism that it goes in order. It does have to be this part matching with this part, whereas transitive, with equations, you can flip things around. But yeah, it does kind of seem like transitive. Okay, all fish can swim. Fonzo can swim. Therefore, Fonzo's a fish. You already answered. You already answered. Maggie?
It's invalid because
Okay, so if you put this into if-then form, what would this be in if-then form? Okay, if an animal is a fish, oops, flying extra M there. If an animal is a fish, then it swims. Okay, Fonzo swimming is referring to the conclusion. Therefore, you're not able to say that Fonzo's a fish. Like, Fonzo could be what?
Fonzo could be a dog.
Fonzo could be a dog. Dogs swim. What else swims? Dolphins swim.
I swim.
People swim. Okay, so all fish can swim is kind of irrelevant to the fact that Fonzo swims, because Fonzo, we don't know anything about him. Okay, was that the end? That's the end.
What is it?
What?
Not an animal. It's
Organisms? What are you talking about?
Like, you know how you call like a snake or whatever.
Like a reptile and like a,
Yeah. What is it?
it's a fish? I don't know. Because an amphibian is like land and water. Maybe this is a fish. I don't know. Google it. Don't know. Deep questions. It's been a long time since I had biology. Okay, let me glance back at lesson 2, 5 notes and see if there's anything else we need to finish. Was there a proof on there we hadn't done? Oh my gosh, there's a lot we haven't done. I forgot. Okay, so this one is super important. I don't know if that came up on, I don't think that came up on any of those proofs, did it? The definition of congruence. Okay, go back to lesson 2.5 and we will do a little bit of this. I don't really care. We won't bother with that one. I don't really care about that one. Okay, but I do want us to go through the proofs and examples.
a mammal.
A fish is not a mammal.
No, I was thinking of.
Oh, okay. I thought you wanted to know what a fish is. A fish is a fish, right?
I couldn't think of the word.
Okay, Jerron. Notes, lesson 2.5. All right, so we're going to go back up to those in a minute, but I want to make sure we focus on this because this is something easy that we just need to make sure we talk about. Definition of congruence. Whenever you're doing a proof and it goes from A, B is equal, like two things are equal to the segments being congruent, that is definition of congruent segments. Or vice versa, it could go either way. If you've got a step that says the segments are congruent, and then it goes backwards and says that the lengths are equal, that's definition of congruent segments. Same thing for angles. If it switches between the measures are equal to the angles are congruent, or vice versa, that's definition of congruent angles. Okay, so whichever way you're going. That means if you're in a proof, if you're doing a proof and it says, like step number 1 says angle 5 is congruent to angle 7. Let's say that's given. And then in your second step, it says the measure of angle 5 equals the measure of angle 7. The reason for that will be what? Okay, it's definition of what? Congruent angles. Okay, definition of congruent angles. Now, it might go from congruence to equality, or it might be from equality to congruence. Same thing with segments. Let's say step 1 said XY is equal to PQ. And that was like given or whatever, it doesn't really matter. But if step 2, if the reason is definition of congruent segments, I usually don't write I usually write it like this. What would that step 2 say? XY equals PQ, what would step 2 say? You got to go from equality into congruence. So what would it say?
Measuring, but there has to be
How do you say the measure of a segment? XY is actually the length of segment XY. So you're going to put it back into a segment. And it would be what? We're switching from equal to congruent. Okay. If you want to just write definition of congruence, I'm okay with that. You don't have to even write, like up here, you can just write definition of congruence. You don't have to write congruent segments or congruent angles. You can just say, I know what congruent means, and that's what it means. And again, all that you're doing is you're switching between congruence and equality, and the notation changes a little bit. But if you switch between equal and congruent, that is definition of congruence for segments or angles. You can say definition of congruent angles, or you can say definition of congruent segments, or you can just leave it as definition of congruence. Okay, let's talk through solving an equation here. So step number 1, our given was -5 times the quantity x plus 4 equals 70. Do you know what the last step is going to be? X equals -18. The statement will be what you're trying to prove, right? So we know when we start the problem that x equals -18. Our given is the equation. If, remember, this is your hypothesis, that's your given, and this is your conclusion, that's your proof. If -5 times the quantity x plus 4 equals 70, then prove that x equals -18. All right, so step 1 is our given. Dirtla, what do you think you would do next if you're trying to solve that for x? Okay. What would that be when you distribute? Equals 70. Distributive property. And it's technically not of equality, but again, if you write equality on that one, I'm okay with that. All right, we have 2 more steps until we're finished. So notice that x is on the left side, which means you want to leave x where it is. What would you do next, Brady? Add 20. If you need to, again, if you need to kind of do this step to make sure you don't do anything silly, then just write it down. Just make sure that you show then what you did was -5x is equal to 90. So that property is what? Whoops. Addition property of equality. Okay, and then Sean, what's the last one? What are you dividing by? You're dividing by -5 on both sides. That's typically what people will say. You could call that multiplication. Most people would not call it multiplication, but if you did call it multiplication, it's because you'd be multiplying by -1/5. That's kind of weird. Most people will not do that, but just make sure it's what you did to that step to get to here. That's what you write there. One last thing before I forget, Diane, hold on a second. Okay, so distributive property is not technically a property of equality. It's really called distributive property of multiplication over addition, or distributive property of multiplication over subtraction. But I don't want you to have to write all that out. So if you write property of equality, I'm not going to care. That's fine. So if you just want to get in the habit of always writing property of equality or property of congruence, then it'll end up on there. I don't care. But technically, it's not actually property of equality. Tell me why it's wrong to use prove as a reason. You're never supposed to put prove. Why not? Okay, proving is the process, right? the prove is a verb. Prove is, okay, now show that this is true. Is this inductive or deductive reasoning? Which one? And what did, was that you? What did you say? Deductive? Yes. Deductive, because you're going step by step, explaining from one step to the next. Okay, I want to hear from some people who have not talked to me today. If you know an answer, then you should answer the question, because then I will call on you on one that you may not know. Diamond, you're not answering any questions. Do you have a question? Or do you want to answer? Okay, you're not answering. Kendall, what's number one? Symmetric property of equality. Okay, all right. Kind of hard to squeeze that in there. On our homework tonight, there's also kind of hard to squeeze it in. Okay, it's symmetric because you're taking the two sides and you're switching them around, right? Switch is symmetric. All right, number three, I'm just gonna go down. Number three, Lily, what's that? Reflexive what? Property of equality. What is number five? Gabe, what do you think? If it's transitive, there has to be two givens. It has to be if this and this. Okay, there's always two equations that you're putting together if it's transitive. So it cannot be transitive. If you have a second guess, you can. Otherwise, but Michael's looks like she's ready. Okay, so let's kind of see what's going on here. I'm going to highlight, here's XM, here's XM, here is XY, and here's XY, and then here's YZ, and here's YZ. Okay, so basically, the purple thing switched sides, right? Because the purple is now with the green. So if it got moved over to be with the green, is that subtraction? Okay, does that subtraction? It's what? Addition. That was a little tricky also because they in addition to adding, they also switched the sides around. So I kind of don't like that too much, but it is what it is. Okay, so that would be addition because you added YZ on both sides. Okay, if the measure of A plus measure of B is 90 and measure of A is 30, then 30 plus measure of B equals 90. Michael? Substitution. Good. So what are you substituting? Well, let's see. Right here, you have the measure of angle A. It's equal to 30. And so we're just going to put 30 there instead of the measure of angle A. All right, someone else. Is that also... So that one is substitution. Is that also transitive? Is that also transitive or no? Jake, is that one transitive also?
Number 7?
Yes.
That's what I wrote down.
Okay, do you think it's substitution or no?
Yeah.
Okay, tell me how it's transitive.
We didn't keep
That's one thing.
and
Okay, that's thing 2. That's thing 3, and that's thing 4. So it's just substitution. Okay, a whole entire side of one of the given equations has to match a whole entire side of the other equation for it to be transitive. So because there's not a measure of angle A plus B over here anywhere, and because there's not a 90 over here anywhere, it's not possible to call it transitive. See, that one is only substitution. All right, let's jump over here. I have not talked to Lily. I have not talked to Drew. I have not talked to Ryan. Did you answer a question? Yes, you did. I don't think I've talked to Grant. Grant, pick one that you can answer. Any one of those you like. I'm sorry. I just didn't hear you. Number 6 is distributive, yes. And again, technically distributive is not a property of equality, but if you write property of equality, I'm not upset. Okay, Drew, pick one you can do. Okay, what is it? It's what? What are you divided by? 7. Okay, and again, you're always going forward. So if you divide both sides by 7, then you'll have x equals 6. Good. That's division, property of equality. Lily, which one can you do? Good. Number 2 is subtraction. We're taking away 3 on both sides. And again, remember, we're not going to write that, because if we write that, Colleen, what's the problem with that? What's wrong with you writing this? Yeah, so just make sure there's at least 4 letters there, okay? And this one was subtraction, at least that, if not the word subtract, okay? Subtraction, not substitution, subtraction, property of equality. And then Diamond wants to do the last one.
I think that
Okay, why? Tell me why it's substitution.
I think because, but
Mm-hmm. You're basically taking that and putting that in place of y plus 3. Right? Since x and y plus 3 are the same, you're substituting, okay?
but it couldn't be transitive because it's not the same. Like how you said, if you box them up, like we have to do like the same thing outside or whatever.
Okay, so here's thing 1. Let me circle. Here's thing 1. This is thing 2. What's that?
That's what you said.
And this is, you know how you just said it's if it's substitution and then it's also transitive? It's both, right? When I look at that, I see transitive first because I just look at, oh, look, it matches, and I don't have to think about it that much. So, okay, those are the same. We can just cross that out and make those equal. But either one is fine. You can say substitution or you can say transitive. You do not have to say both. Okay, unless I specifically say, you know, give all the possible answers. Generally speaking, you're just going to tell me one or the other, and either one is fine. You don't have to say both, but it would be both. I'd accept both answers.